Hello, we're going to continue talking about conditions for unique triangles. Today we're going to focus on when we're given two angles and a side. The other day we talked about side angle side and side side side, and so what we want to do is start to compare when we're given two angles and some side. So as we read through this, some of the vocabulary: side, angle, included between, and congruency. Triangle XYZ has angle measures of 30 degrees and 50 degrees, and then the included side. So what does included mean? It seems to be one of those words that students struggle with, but between. And so it's between X and Y. And it should make sense since the vertices that make up this line are X and Y, and also the angles. So we're going to draw X prime, Y prime, Z prime under the same conditions, and I'm going to show you how to do it a couple different ways and see if we like that. But first of all, we need to start with a line, okay, because that gives us the basis for our 30-degree angle. So 30 degrees. And we don't know how long we need to make this line, so I'm going to extend it all the way up. So this is 30 degrees. They told us that this is X. We need 6 centimeters between it and Y, so I'm going to go through here. 6. Take that point, so this is 6 centimeters, and make my 50-degree angle. And so this is Z. This is 50 degrees. If we want triangles, we could do side angle side, because we know that theorem, or side side side. And so here, let me just get some quick measurements down in case we want to use either one of those. All right, so this is my triangle. This is what I'm going to base the next one off of. Okay, again, we'll start with a straight edge. We'll put it at a diagonal. It says it wants a 6 centimeter line. I'm a little crazy with that line. Okay, so here's marks off 6 centimeters. And from there we'll make our two 30s, and we'll see if everything matches up. So here's a 30. And then we'll make a 50. So this was 30, this was 50, this was my 6 centimeters. And let's just see if after these constructions, if they actually are the same. First thing, the angle. Is this angle congruent to that angle? And we're going to see that it's roughly, aside from maybe some human error, 100 degrees. And this one looks like it's pointing at 100 degrees also. We're going to learn that knowing that all three angles are congruent is not enough to prove congruency, angles alone, but we can certainly start there and know that at least the angles are congruent, as we know we need for congruency. Next thing I would do is I would just measure. If I have 3 equal sides, then I know I have 3 equal angles, and you can see that this is 3 centimeters. The former one was 3 centimeters, and this one's 3 centimeters, or 4.6 centimeters, just like the last one. And so despite sort of rotating the orientation a little bit, I see that I have exactly the same triangle. So knowing that you have an angle, a side, and an angle is enough information to determine unique triangles. And ultimately what this is, it's kind of like the side angle side and the side 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 piece. It's a congruency reason. Okay? One thing you might want to make sure you understand is this is the two angles and the included. Get used to that vocabulary word, included side. Okay? Now you might be wondering or asking yourself, does it work anytime I have two angles? And so we have this problem on the back. Two sides. Oh,